Okay, so we're going to let this cursive A be an index collection of sets where the index set is delta and this alpha just represents any set within this collection here. Okay, so the reason why it's written like this is because this collection can have countably many sets within it or uncountably many sets within it. It doesn't matter. This property will still hold regardless of how big this cursive A is. Okay, so the property says the complement of the intersection of the sets within this collection is equal to the union of the complement of these sets within this collection. So we're going to prove this using some logic. So let's go ahead and get started. So first we're going to start off with X is an element of this intersection. Is an element of the complement of this intersection, right? So if that's the case, right, this means that X is not an element of this intersection, right? Okay, so if X is not an element of this intersection, this means that it is not the case that for every alpha contained in this index set delta, we have X as an element of A sub alpha. Now we can write this nice and compact using some logical symbols. So this is the same thing as the negation of for every alpha contained in delta, we have X as an element of A sub alpha. Now we know that the negation of a for every statement turns into an existential statement. So this is the same thing as there exists. So when we used alpha, it represented any element in the index set, indicating any set within the collection. Now, for an existential statement, there only needs to be one within this collection that has this certain property to make it true. So we're going to use a dummy variable. Let's call it beta. There exists a beta contained in delta such that X is not an element of A sub beta. So beta is just a dummy variable. Alpha represented every set within the index, every set within the collection or any element in the index set. Beta represents some elements in the index set, right? Some or several. It doesn't matter. It just represents one or many within this that have this property. So once we have this, we can rewrite this as there exists a beta contained in delta where X is an element of A sub beta complement. Now, this is literally the definition of what we're looking for. This means that X is an element of the union of the alphas in this index set of A sub alpha complement. So what we got was that X is an element of this, the complement of this intersection, right? If and only if X is an element of the union of the complements of these sets within the collection, right? And this literally shows that this intersection, the complement of this intersection, right, is equal to the union of these complements, right? And that's what we set out to do. That is the proof.